Hi everyone, this is Howard. Welcome to another Star Talk Tuesday. This Tuesday's August 18th. Now we have a pretty cool thing. Actually, it's actually a rare event and it's cataloged as rare. I would call it, if you pay attention a lot, it's probably more like uncommon, but and I won't be ambiguous here. We have a rare double shadow transit occurring on the face of Jupiter on this particular evening. Now, we just had one. Ironically, as rare as they claim these things are, that's why I say they're kind of uncommon. You don't see them very frequently. They happen all the time. It's just not always conducive to viewing. What happens is moons of Jupiter, in particular the Galilean moons, four of them, as they orbit between us and Jupiter as we're observing it, the sun's light, of course, is reflecting off those moons, which then means that as they pass across the face of Jupiter, they leave their shadow on the face of the planet. And you can see these shadow transits occurring. Typically, you'll see one of the shadows at least once a week. But to see two is fairly uncommon, or as you'll read in the news, rare. And what's interesting is we just had one last week, and we had the moons Io and Ganymede with the great red spot passing across the face of the moon. Passing across the face of Jupiter, those moons leaving two shadows across the face along with the great red spot. It was a spectacular thing to see if the weather was just agreeable. It's happening again. So this rare event is going to happen basically twice in 7 days. And this time it's going to be flip-flop, but it's the same two moons. Now there are four, but it's again Io and Ganymede, but they flip-flop, so this time while Ganymede is still preceding Io, their differences in distance will allow Io's shadow to precede Ganymede's this time rather than Ganymede preceding it the previous time. Anyway, I don't want to get all complicated in the semantics of it. We're going to see two shadows across the face of Jupiter on the evening of the 21st. So Friday night into, it's actually, you can start your observing Friday night, but the event will actually occur very early in the morning on the 22nd. And then we have some pretty interesting things about the moon that I want to get into. So let's just, on that evening of the 22nd, so let's go ahead and let's just do our usual. Let's go ahead and accelerate the clock. This time I'm facing west this time instead of having to flip it over there. I finally learned after, I don't know, about 20 episodes, let's just start facing west. That makes more sense. I learned slow. All right, so now we get to watch our beautiful digital stellarium sunset. And just as the sun goes down, there we go. Right about here. Now you'll notice the moon is up. Of course, we noticed that already, but I want to point it out first in its current condition because we want to visit this again tomorrow night, being Saturday night, of course. And so while the shadow here still reveals a lot of the moon, and potentially sometimes you look at the moon up there and you get what's called earth shine, light reflecting off the earth, then reflects off the part of the moon where you typically wouldn't be seeing, and it's bright enough for you to see fairly well. That's what they call earth shine. So it looks kind of like earth shine, but in reality it'll be fairly dark. And you can see where the terminator is, and it's right up there against this edge of this crater, or excuse me, this mare here. We're going to visit this tomorrow night because the shadow will have moved a little bit further over, and we'll have a little bit of an interesting part of the moon to talk about there. So let's pull a little bit further back out. And now we shift over here into the southern part of our sky, and there we see Jupiter and Saturn dominating the sky, of course. We've got a spectacular thing happening in December, and I know I've mentioned this in the past, but I'll be bringing this up quite frequently, and that is what's called the Great Conjunction, and that is basically a conjunction is when two objects appear very, very close to each other. In this case, Saturn and Jupiter don't look like they're very close to each other, but on December 12th, 2020, December 21st, 2020, Jupiter and Saturn will be so close together that it will be really, well, you could barely make out to be about 0.1 degree of a gap between them, meaning it will be as close as they have been since 1623. So that's what they call the Great Conjunction. It happens every 20 years. The Earth and the planets, Jupiter and Saturn, line up just in a way where we see Jupiter and Saturn appear very, very close. So what we're watching here is kind of like the New Year's Eve ball drop, where we watch Jupiter and Saturn slowly getting closer and closer together. Now that ball drop typically takes 60 seconds on New Year's Eve. This one's going to take, well, we got a few months to go. But as we watch over the next few weeks and months, we'll see Jupiter and Saturn get closer and closer together in the sky. So always pay attention. That's the ongoing thing. They are absolutely spectacular in the sky. You really can't miss them. In fact, I frequently get a lot of people that call in or email and ask, what are those two really bright things in the sky? And yes, of course, Jupiter and Saturn. Now, let's go ahead and let's bring it into Jupiter, because we want to make this about Jupiter's view tonight. So let's lock in on that, and we bring the view in. There we go. We can see those moons. These moons. Now, we'll bring this a little bit better. There's Ganymede and there's Io. Now, moons that are moving from east to west in this direction are passing between us and Jupiter, meaning Earth, us observers on the Earth, and Jupiter. Moons that are moving from west to east are on the other side, passing around behind Jupiter. So I believe Europa has already passed around and is going to be coming back around this way, but Ganymede and Io should be moving in this direction from east to west. So as we bring in the view, let's add a little bit of time. There we go. Yep. Europa is coming around the bend, it looks like. Now, Ganymede is preceding Io, but because it's further away, its shadow will take a little bit longer time to catch up and actually land on the face of the planet. So here comes Io, and there's Io's shadow, and there's Ganymede's. Now let's bring this in. Now, as you can clearly see, Ganymede has already... In fact, let's take that back a little bit. We'll watch that again. I'm so redundant. So here we go. You can see now, right now, both moons are transiting the face of the planet. So as you look right now, we got this spectacular trio, this arrangement. We've got Ganymede, Io, and the Great Red Spot. And the Great Red Spot's kind of staring out at us like some sort of cycloptic eye, like the Eye of Sauron here. He's got two moles up there. But this is going to very rapidly change. And as we add that time, again, we watch how very quickly they move out of the view. Ganymede, and there are their shadows. I'll go back to here, and now let's pause it for just a moment. So when I actually calculated this before, I thought the Great Red Spot would have rolled out of the view already. I didn't realize they'd actually be a repeat of what we had just last week, which was Ganymede and Io with the Great Red Spot. I initially thought it was just going to be the two shadows, but we get the Great Red Spot with us, the GRS. If you're in the know, you call it the GRS. Anyway, the Great Red Spot, Io's shadow, and Ganymede's shadow. See, now Ganymede's shadow is clearly lagging behind, and that's because of the greater distance that Ganymede is away from the planet itself. So its shadow takes a little bit longer to get onto the planet, and as you can see, it's trailing behind. And eventually, as we roll on time, maybe a little bit quicker, there we go. Oh, and of course, they dip below the horizon. In fact, I wasn't paying attention to that. You have to be aware of that. Let's bring that back. We're probably really low when this is happening, so let's see where we are relative to the horizon. There we go. Yeah, you can see we're really low. So this is 3 o'clock in the morning. So yes, folks, astronomy is a hobby that requires a little bit of dedication to the craft, because the best things don't always happen at the most opportune times. But to get a relatively rare double shadow transit, be able to see this occur over the span of an evening, watching it from the early evening, watching as Io and Ganymede were on the eastern side, shifting over to the western side and trailing and dragging their shadows with it across the face of Jupiter is a really spectacular thing, especially for a long evening out under the stars. All right, now let's back this up a little bit. And when I say back it up, I'm really going to move it forward. I don't want to have to go through daytime again, so I'm just going to back up the clock. I want to go too quick. There we go. We're going to back this up to somewhere around just after sunset. And then we're going to move the clock forward. I just don't want to have to go through the daytime because I want you to see what's going to happen tomorrow night. So we are now, we were in the morning of the 22nd. So right about here, this is good. And now I'm just going to cheat and move the clock forward one day. So now we're August 22nd. It's about 9 o'clock in the evening. And we were just looking at Jupiter. We want to come over here and look at the moon now. Remember, I mentioned this earlier. The moon will have shifted a little bit, so let's bring this in. Now, this is 9 o'clock, so it's not too late. Still above the horizon. And now we're going to zoom in. And what we see is a waxing crescent moon here. And there's that terminator. It's much further away from that mare that we see there. This is sort of a Latin for ocean. We've got another one down here, and I don't want to give away their names yet, but what we've got are these two fairly prominent visual features that you can identify with telescopes and, of course, binoculars. Modest binoculars will give you a fairly good view, but the moon, if you have a telescope, even if it's a lower-end telescope, if you're able to manage to aim it at the moon, even with a low-power eyepiece, and if you've got a set like this, the higher the number, the lower the power. Don't be tricked by this. If you've got a really low number, that's high power. Don't start with high power. But the moon, you'll eventually want to move up to medium power if you can get to it. And check out the edges of the mares here. And I'm going to kind of cheat here because I'm going to use a different program to kind of illustrate this. But if we bring this in, this mare here is called, my memory, come on, don't fail me now. Oh yeah, this is the Sea of Crises, and this is the Sea of Fertility here. And while these are beautiful here in this view, it doesn't quite reveal the detail here. And with the terminator over here, this is a spectacular time to look because the light is coming at a particular angle, and jagged features along these edges here where the ridges are. Anything bumpy on the moon under extreme light at extreme angles will leave beautiful shadows, and it's these interplay between bumpy edges and the shadows that they create that give this enormous sense of realism. I mean, it's a place that you can recognize. It looks almost terrestrial, like, well, maybe somewhere like Idaho, but in a very barren, well, the barren part of Idaho, if you haven't been there on the eastern side, it's almost like lunar landscape there, but it is somewhat Earth-like, and there's almost a sense of familiarity under high-power views of the moon. It's one of the most stunning things to look at, and thankfully, one of the easiest things to find. So, what I wanted to show you was I'm going to cheat now, and I'm going to just switch over. We're going to turn this off, and this is another program I use called Worldwide Telescope, and we're now looking at the same area. In fact, I could do this, and we could pull this all the way out to here. And there's the Earth. We could replicate the view. So there's planet Earth, and we'll line it up with the moon. So this is roughly the same time and the same date. There's planet Earth. And we flew right through it. So I can kind of simulate the view of the moon. It's trying to drag me over into this view. So there are those two mare that we were looking at. There is the Sea of Crises, and this is the Sea of Fertility. These are areas that you can look at, and as you can see, there are those bumpy edges. And now, ironically, the shadows here are with the light coming from a different direction. The light at this particular time will cast shadows this way, and so you'll see an interesting interplay of light. Now, this, just to give you a sense of scale, because it really is hard to gauge how big is this thing. Well, it was interesting. I was curious about the width of this particular Sea of Crises here, and I remembered a vague notion of how big the United States looked, and I thought, you know what, I'm just curious. I looked it up. The distance, the diameter of the Sea of Crises is 345 miles in diameter. And that is precisely, this is what I thought. I was kind of curious. I looked it up. That is exactly the distance between Miami and Jacksonville, 345 miles. So you can kind of visualize Florida laying over this thing to give you a sense of how big it is. This is just a giant sort of flat lava field. And there's these impact craters in the area. These are all things that you'll be able to visualize in telescope. I'm not telling you or showing you things that you can't see. I want to kind of connect it to history. So really quickly, this crater is named after Jean Piccard, And if you're a Star Trek Next Generation fan, this is not named after Jean-Luc. Jean Picard was a French astronomer who in 1670 calculated to a really reasonable degree of accuracy the size of the Earth. And of course, to honor him for this accomplishment, they named this particular impact crater here after him. And over here is, this is Pierce Crater. This is named after an American mathematician named Benjamin Pierce, who taught at Harvard, who I can't even get into his mathematical contributions. It requires almost a degree just to say the words. Anyway, this particular mare here has another interesting connection to history. Now, if I mention to you what happened on the moon on July 21st, 1969, and of course, everyone will say Apollo 11 landed on the moon. What you may not know is that something else kind of landed on the moon on July 21st, 1969. It didn't really land. It was called Luna 15. And it was interesting from a historical perspective that on July 21st, 1969, that day represented the culmination of the efforts of two nations' attempts to get to the moon. One, of course, we understand historically as Apollo 11, the successful landing of humans on the moon. Luna 15 was the Soviet attempt to land a sort of a rover on the moon that I believe had all kinds of interesting lab equipment to run tests on the moon. But unfortunately, now, hours after Armstrong and Aldrin had landed, the Luna 15 mission was just getting ready to begin its descent. And then not long after, or not long before they were actually scheduled to leave the moon, meaning Armstrong and Aldrin, they lost contact with Luna 15 and it crashed into the surface of the moon. Now, where did it crash? It actually crashed somewhere right about here, almost in the center of the Sea of Crises. Now, I find that interesting that name, Crises, it seems like that's name that resonates with the times here. But that you can't see the crash site. I'm not even trying to suggest that. But as you look up here, what I love about the Sea of Crises here is you look at the moon. It's kind of isolated. It's all by itself, not connected to anything else, sort of you'll see that as the moon starts to get fuller, you'll see the mare are all kind of interconnected. But the Sea of Crises here is all by itself. And there are these very obvious lunar impact craters you can see. Now, I don't want to leave out this one over here. The Sea of Fertility is connected also to this particular crater. These are areas, this is Lagranus. I'm probably butchering the name, but these are all areas where you can see fantastic texture across the sky, or across the moon, as you watch the shadows. And of course, as you're observing time, the moon is shifting, and as you notice along the terminator, you'll see areas where there was no detail because it was lost in shadow. As you observe over time, the terminator shifts and starts to reveal more and more, and shadows get shorter and shorter as the terminator continues to shift. Anyway, I think I've blathered on far too long. We're going to try and wrap this up. Ladies and gentlemen, thanks again for joining us. Don't forget, we've got Jupiter and Saturn continuously shifting through the sky. We've also got Mars coming up. We're going to spend a lot of time on Mars in the next month. Now, this is a quick reminder. On August 22nd, this is not just the day of this opportunity to look at the moon. That's the morning of, the night after you've looked at Jupiter and you've seen this double shadow transit, because I know everybody's going to do that. We get an awesome opportunity to discuss that. If you want to come and join us at KidSpace, if you want to go to our website, bishopscience.org, you can register for our KidSpace program. This is a program where we like to engage the kids with space. We answer any questions that they may have. And we're certainly going to be discussing the shadow transit from the night before, and of course encouraging everyone, reminding everyone to take a look at these beautiful features on the moon. Anyway, again, thanks again for joining us, folks. We'll catch you next time.